Hello, and welcome to today's lesson on the balance between radiation and emission and how it affects temperature. Our plan for this lesson is as follows. We will begin by understanding how the temperature of a body depends on the balance between radiation absorbed and radiation emitted. Next, we will then highlight these ideas with an illustrative example. Finally, we will explore how this concept is applied in real-life scenarios. Previously, we have delved into the basics of waves and radiation, focusing on their properties and interactions. You have learned about different types of waves, their behaviors, and how they transfer energy. With this prior knowledge, we can now explore how the balance between radiation absorption and emission governs temperature changes. This concept will advance our understanding of thermal dynamics and energy balance, which are crucial in both natural and technological contexts. Let's get started. Let's start with a key concept. The temperature of any object is influenced by the balance between the radiation it absorbs and the radiation it emits. This is a fundamental principle in understanding thermal dynamics. Firstly, if an object absorbs radiation faster than it emits, its temperature will increase. Conversely, if it emits radiation faster than it absorbs, its temperature will decrease. When the rate of absorption equals the rate of emission, the object will maintain a constant temperature. This balance point is crucial for understanding how objects regulate their temperature in different environments. To illustrate this concept, let's consider an object placed in an oven. Initially, the object is cooler than the surrounding environment inside the oven. When placed in the oven, the object absorbs thermal radiation from the oven's hotter interior, causing its temperature to rise. As the object's temperature increases, it starts emitting its own radiation more effectively. This continues until a point of equilibrium is reached where the object absorbs and emits radiation at the same rate. At this equilibrium, the object's temperature stabilises and becomes equal to the oven's temperature. So even though radiation continues to be exchanged, the object maintains a constant temperature because its absorption rate matches its emission rate. This concept extends beyond theoretical scenarios and finds practical use in real-life applications, such as emergency blankets. Rescue teams often use light-coloured, shiny emergency blankets to keep accident survivors warm. A light, shiny surface reflects and emits much less radiation compared to a dark, matte surface. This property helps to minimize the amount of infrared radiation the blanket emits, thus keeping the patient warmer. Essentially, by reducing the rate at which the patient emits radiation, the blanket ensures that the patient's body absorbs more radiation than it emits. This helps in retaining the body's heat, thereby keeping the patient warm under emergency conditions. In today's lesson, we examined the balance between radiation absorption and emission and its impact on temperature. We learned that an object's temperature increases if it absorbs radiation faster than it emits, and decreases if it emits radiation faster than it absorbs. When the rates of absorption and emission are equal, the temperature remains constant. We then illustrated this concept by considering an object placed in an oven, where it heats up until it reaches thermal equilibrium with its surroundings. Additionally, we explored practical applications, such as the use of emergency blankets by rescue teams to retain heat in accident survivors. Watch the rest of the GCSE Physics course at Sophos Education.